Now continuing with the last two Z values corresponding to 98% and 99% CI, we again draw the curve. We allocate 98% probability to the center of the curve. Consequently, remaining 2% of the probability we need to equally assign to the tail end regions. Now we need to go to locate 0.01 probability or value of z corresponding to 0.01 probability. So 0.01 probability or any closer value to it we can spot over here. So that's minus 2.30, 2.31, 2.32. So it's 2.31 and 2.32. So again we go for the average because both the values are almost at the same distance. So minus 2.32 and minus 2.33 will give us the average of minus 2.325 and plus 2.325 for both lower and upper bounds, and we can code this value as the z value corresponding to 98% confidence interval. Now going to the last case of 99% CI, point 99, 0.005 here, which is half of 1%, and 0.005 here. Now we are going to locate probability corresponding to or nearer to 0.005, that is in this row. 0.0051 and 0.0049, these two neighborhood probabilities are again at the same distance from the target probability of 0.005. Therefore, we read out the locations of these two probabilities in terms of z values, and then we go for the average. So minus 2.5857 and 2.58. So minus 2.57 minus 2.58 gives us the average value of minus 2.575. So we will take the values of z as plus 2.575 and minus 2.575, and this is how we quote this value of z across 99% CI. So these are the 5 commonly used confidence intervals and their corresponding z values that we'll make use whenever we are asked to construct a specific percentage of confidence interval to estimate population mean. Now to apply this formula in a given situation, let's take an example that we have taken a sample size of 30 individuals. Regarding that sample, we are assuming that the variable we are focusing on is normally distributed across the entire population. So let's take an example. If we assume that the mean income in dollars of a selected town is represented on the basis of 30 individuals selected at random from that population, and we assume that the incomes are normally distributed, So X bar, let's suppose it can be taken as the hourly wage, and let's assume that the minimum hourly wage in this town is $25 an hour with a standard deviation of $5 per hour. And if you are asked to construct 95% confidence interval for population mean mu. So what we do, we need to write down the formula first of all, and then since we are asked for 95% CI to be constructed for this population mean, therefore we will also get the Z alpha by 2 value corresponding to 95% CI, which is 1.96 we have got from the table. I just have a look at it again. From this table, we have selected or chosen 95% CI value is 1.96. Now, substituting the value in the formula in place of mean 25, in place of Z alpha by 2 1.96, then $5 divided by square root of 30, then $25 plus 1.96, 5 divided by square root of 30. And now what we do, we will compute this part first of all, and what value it would give us 1.96 times 5, and then divide this answer by square root of 30, which is your sample size. So 1.789 is the value of this entire part that can be rounded off to two decimal places, because currency we take up to two decimal places, so better to round it off to two decimal places, and that would give us 1.79. Now getting this 1.79 subtracted from 25 and added to 25 would give us the lower and upper bounds of the mean value. So that is 23.21 and 26.79. Now, how do we interpret these two answers? What we have done? We have constructed 95% confidence interval to determine the mean income of the people, or mean hourly wage or mean wage of the people who are living in this town. So we can state it as, we can be 95% confident that the mean wage of all the people who are living in this town lies between 23.21 and $26.79. This is what we can do, or this is how we can interpret the answer. Now, focusing more on the formula, we need to understand two additional concepts. I'm writing down or copying down the formula again. The terms that we are adding and subtracting to the mean value or from the mean value, in fact, it is making the difference in the two answers mainly. And extracting out this factor that we refer as margin of error in estimation, we call this margin of error in estimation. Okay, now we can determine with the help of this formula that we have applied already in the confidence interval, and we can in fact quote the value for the given data what we have just used in the previous question. That's 1.79, I believe. So minus and plus 1.79. Now, how do we interpret this? To understand the interpretation of this particular term, what we refer as margin of error in estimation, we need to understand what we are looking for and what we are getting. We are looking for the population mean that lies in the center, we understand, or what we know. First of all, we have a glimpse of this population mean based upon the sample data we draw from the population, assuming that the data are true representative of the population, the sample data, what we have drawn. Now, we first estimate, compute population sample mean from that data. And this sample mean we refer as point estimation. What do we call, or why do we call point estimation? Because every sample can give us only one value for the mean. So point means referring a single answer. So point estimation of mu is x bar, or x bar is referred as point estimation of mu, we can say. Now with the help of adjusting some factor, what we are calling margin of error, so getting a margin of error subtracted from this and adding the margin of error to it for a 95% CI, or for any given percentage of CI, we are getting the lower bound and the upper bound for the answer. What we have done, 25 take away 1.79 and 25 1.79 added to it, we get the lower and upper bounds. So the lower and upper bounds of the unknown population mean mu, what we are determining, is within 1.79 dollars away from the population mean value. And this is how we interpret margin of error. Margin of error. Usually we are asked for interpretation of margin of error component. In this application, what we have taken as example, plus minus 1.79, that is referred as a margin of error in estimation. We interpret this as the estimated mean this is the mean for mean hourly wages. So mean hourly wage, the estimated mean hourly wage lies within 1.79. Over here we need to ignore the plus minus sign because this English word within refers the plus minus sign indication. So lies within $1.79 of mu. This is how we interpret the answer for the margin of error in estimation. The estimated mean hourly wage lies within $1.79 of mu. Taking the formula again, the formula for margin of error in estimation, we can determine the formula for the sample size by making the subject of the formula or changing it to n. So we can swap this square root of n written on the right hand side denominator part with e, which is written on the left hand side. So swapping these two terms, we get square root of n now. Currently, square root in n, what we are going to determine is in the square root structure. So we have to remove that square root. So to get a square root removed from both the sides, we need to while squaring both the sides of the equation, we get a square root of n square, and this is plus minus the alpha by 2 sigma divided by e whole squared. Now on the left hand side, we will be left with n, and when we apply this whole square inside the bracket, the plus minus sign will be eliminated and the square will be applied to each term involved in the computation. So this is the z value squared of that. This is standard deviation squared or variance, and this is margin of error squared. Better if we leave it in whole squared structure, because what I have noticed that applying individual square to the formula sometimes needs your proper attention in the exam, because ignoring a square value anywhere will induce the error in the answer. Therefore, it is recommended to leave it as a whole square, substitute each value in its place, and then determine the answer. Now, currently the margin of error was 1.79. We would like to reduce margin of error in estimation. And over here we can take notice of one thing, that if we would like to reduce margin of error, we need to change the sample size, because there is an inverse relationship between square root of the sample size and the margin of error in estimation. So what if we would like to reduce margin of error from minus 1 points or plus minus 1.79 on absolute terms, from $1.79 to $1.2. So this is the new margin of error value. $1.2 is the new value for the margin of error. So we need to determine the sample size desired to reduce the margin of error from 1.79 to 1.2. For this purpose, what we do, we will substitute 1.96, assume that the 95% CI still remains the same. We are asked to decrease the margin of error for 95% CI. Sigma was already given as $5. So what we do, we need to substitute in place of z 1.96. Sigma should be substituted as 5, and margin of error should be substituted as 1.2, and now raise it to square. So 1.96 times 5, 1.96 times 5 divided by 1.2, 8.167 and squared. So 8.167 squared is 66.69. What we can do, we need to round it off to the next number. 66.69, if rounded off to the next number, would give you 68. 68, 67 should be the sample size, should be rounded off to 67. 67 should be the sample size that will make sure or reduce the margin of error from 1.79 to 1.2 in the current scenario. This is how we can determine the margin of error as well as determining the sample size for a given margin of error.